The kind of working title I had for this talk was Modern Data and Medieval Methods. And what this is really about is attempting to do continuous delivery or something like it using the tools from the Microsoft Azure data platform. So who am I anyway? Well, my name is Gavin Campbell. I don't normally talk about myself too much at these meetup events, but in this case I think my story is kind of relevant to this story, which is that a long time ago I was actually kind of a proper developer with like pointers and everything. Yeah? We used to check in our code into SourceSafe and then like build the binaries on our desktops and put them on CDs and send them to the customers. And I think even back then I think I realized that this probably wasn't like, you know, a really good way of working, and I did change job to somewhere else, and they were a bit more competent in most respects. But the thing about the somewhere else is that a whole load of their application logic was in these stored procedures in the database. Yeah? So, and this was like, well, 2004, 2005. So they were kind of starting to do the good stuff, like with the front end code, but the back end was still this mess of messy deployment and all the rest of it. So life happened, and I ended up being in charge of a team somewhere else on the other side of the world. And well, what do? Well, you do what you've done before. So we implemented this big system full of these stored procedures. Yeah? And because I was in charge, I thought I'd better read some books about being in charge. And one of them was this book called Extreme Programming. And this was quite an early influence on me. But here we are with this database-intensive application, trying to do all this good stuff with like cruise control and with NUnit and all the rest of it, yeah? With these SQL Server stored procedures. And anyway, after that, back here, I've ended up doing a lot of SQL Server projects and a lot of these BI projects. Yeah? But I've never really had this strong distinction in my head between like SQL Server and BI type development and like developing a website or developing an application. So this is a theme that has been through my work in the last few years, is that, like, you know, we can do these database type things, these BI type things, but can we not at least try and do them properly? Yeah. And anyway, so this is how me, whose day job is really about SQL Server and Jenkins and .NET and those tools and PowerShell, ended up in this. Yeah? So this wasn't my day job project. This was some friends of mine who were doing this big proof of concept with Microsoft Azure. And the idea was to consolidate a bunch of these on-prem reporting systems into this cloud data warehouse. Yeah? And of course, this being, well, it was 2016 at the time that we were looking at this. Big data is an important ingredient in any enterprise solution. Right? So what was it they were going to try and do? Well, they were going to use all of these things here. Microsoft Azure Data Factory, Data Lake Store, and Azure SQL Data Warehouse, right? There's a theme here, yeah? Right, well, I didn't really know too much about any of these things, but the reason I was helping them out was to help them with, like, well, how can we do this stuff and, like, get it delivered in a good way, yeah? So anyway, off to Google to find out about these things. I've got a couple of slides about what these things actually are, in case anyone's unfamiliar, right? So Data Factory, right? This is a kind of a misleading slide, right? Because, and this picture's from Microsoft's website. Because it's got all these things here, like data sources, and it does ingest and prepare and transform and analyze. It doesn't actually do any of those things, really. Yeah? What it is an orchestration tool, yeah? That kind of knows how to read from a bunch of these sources, or has adapters to read from a bunch of things, like SQL databases, like HDFS and all those things. And it knows how to call out to external services, yeah? Like Hive and Spark and some Microsoft hosted services to do computation. And it knows how to write to a bunch of places, yeah? Including HDFS and HDFS-like stores and databases and this SQL data warehouse and all the rest of it. Yeah? So for those of you who are not familiar, this is like Luigi, yeah? Or this is like Airflow, or those tools that kind of don't have anything built in, but kind of know how to coordinate loads of other things. Yeah? And as for Data Lake Store, this was a puzzling one. Yeah? So there's a lot of stuff on this graphic here, but really this is just, well, this is sort of just HDFS in disguise. Yeah? Like, so you can store data into it. The difference, as far as I can tell, is that it is optimized for big data workloads. Yeah? Like, what does this mean? I think, well, it means it costs more. Yeah? Like, and apart from that, I think there's some secret sauce, and this is the secret sauce of it compared to like regular storage, about, you know, high throughput and blah blah blah. Yeah? But anyway, this is a store like any data lake store. Yeah? And finally, SQL Data Warehouse. So this is a bit more than SQL Server in the cloud. It has this way of busting up your data and consequently your queries into all these bits, so they can be executed by a bunch of nodes. It looks kind of like SQL from the outside. with some other tricks that look kind of like Hive from the outside. Yeah, so to be able to create external tables from your SQL database and load the data through them in this highly parallelized fashion. And well, there's some stuff in SQL Server that doesn't work here, like anything that's really a singleton that can't run on 50 nodes at once. And then there's some stuff here that doesn't work in on-prem SQL, so it's kind of overlapping. And so the proof of concept was like this. We're just going to get a SQL database. So the real life project would have been like all those enterprise things you can imagine, like SAP and website analytics and all the rest of it here. And we put all that into this data lake and we do some stuff here. But the simplification was to say, right, we're just going to take a SQL database, use this data factory thing to write some of the rows out to this data lake, and then use Polybase to copy them into our data warehouse. And then one of the things I remembered from kind of doing a lot of BI projects before is that you want to start really with something like this. Yeah. So this is a dashboard that looks rubbish, right? Because it has one measure. Yeah. Right, and this isn't really minimum. This has 2 dimensions instead of 1, but 1 is a good number. Yeah? There's only 1 external dimension, right? And well, the reason you do this and deliver it proudly to the users, yeah, is to make sure that all the bits can actually see each other and talk to each other, yeah. And especially in like a large organization, this is where this gets really hard, yeah, because in these data warehouse and analytics projects, you have this whole thing of like big design up front, it's known as, yeah. Like, and my empirical experience of this is that the big design up front is always correlated with like big difficulties actually getting it deployed. Yeah, and like almost like if there are more than 2 people called enterprise data architect, yeah, you are definitely going to be having problems with the firewall. Yeah, like when it comes time to actually show your things to the world. So this is like something from like old-fashioned on-prem. It's like, yeah, let's just do something small, and at least that way we know that it all kind of works. And then, like progressively, we can add. We're not adding features, but our features are going to be like additional measures and additional dimensions. Yeah? So, what does Data Factory actually look like? This is all kind of a bit small print, isn't it? We sort of see it. The detail is not really important. Yeah. So, this is a Data Factory pipeline. As we can see, it's just loaded JSON. Yeah. And this here is the environment that we get in the Azure portal in the website to do our development of Data Factory. Yeah. And over here on the left are all the other bits, yeah? So we've got some linked services. Those are the things that it can talk to, yeah? Those are just JSON files too. They contain like the connection information, yeah? Some data sets. This is defining the schema of what we're going to load. So obviously for some data source, you don't need a schema because it has one. It's a database. But for others that are just text, you need a schema to be defined in your code. And then the final bit is this pipeline, which is this. And we can see this is just the start of it. This is quite a long file, yeah? And so what we're doing here is reading some data from a database table, and we're going to write it to this data lake. And this, in fact, is an environment you can use to develop your data factory. And this is the environment that kind of every demo uses, right? So if you want to add a new element to it, like, we can right-click over here and add something new. So here we're adding a new data store, yeah? But I get this pop-up. What's this pop-up asking me for, yeah? This is asking me for my Azure creds, yeah? Or some creds that I know, yeah? So I can type them in, yeah? And having done that, then this data factory here is authorized to access that data lake store, yeah? Great, yeah? Well, we'll come to what I think about that in a second, right? And imagine we've got to here, and we can't remember what the name of the database we're going to connect to is to put into the connection string, which is what's going to go into this file, yeah? So we'll just save this and come back later. Well, there isn't a save, yeah? The choices are, right, type code into this window, yeah? Discard and deploy, yeah? So in here, yeah, you want to do this is continuous deployment right here, isn't it, right? Like, you type your code into this window here and paste in your connection stuff, and then it's deployed, right? It is smart enough to know that, connection strings are sensitive and it has to asterisk them out before the next person comes along and reads them, right? So how do we get from here? So imagine that, we've decided to adopt a bit of best practice. We don't just have one environment. We're going to have, this is going to be a development environment, and we want to promote this code to a test environment, right? Or to a production environment. So how do we get the code from that window there into our production data factory. That's the one there, yeah? Right, and in fact, there's an enterprise version of this, yeah, which is to use Word to create a deployment guide, yeah? And then the super enterprise is to store this deployment guide in the team site, yeah? Where no one will ever be able to find it, yeah? Right, and even assuming that you know that you figured out all this, and you've got your Word template for deployment guides, right? Right, what do you do now? Well, what about these creds? Yeah, right. So in that file there, right, we had the credentials, presumably for like the developer's instance of Data Factory. What about the live ones? Yeah, do we trust the developers to know the creds for like all the live data sources? No word of a lie. One of the suggestions I heard for this, right, is well, we can get the developers to do all the fancy stuff with the pipeline and the activities, yeah? And we're going to get another team to log into that portal and set up the connection strings for all of those environments ahead of time, yeah? Because they're kind of static, they don't change very often, right? Can anyone guess what the name of the other team was that was going to do all that? No, it was the DEVOPS team, yeah? So what's the conclusion? So this developing through the portal, right, is great, yeah? And you can do a demonstration with it, yeah? But this doesn't scale beyond one environment, does it? Yeah? And the reason it doesn't scale beyond one environment, like the forgetting about Azure, is there's no source control. Yeah? Like you type your stuff in and it's live. Yeah? So this is the thing that stops this approach from scaling. Yeah? But never fear, right? Data Factory tools with Visual Studio. So you'll notice that this is only for Visual Studio 2015, which I think the writing might be on the wall for this, right? And it has 2 stars. Yeah. Like, Chicken Cottage in Bromley has 2.5 stars for reference. Yeah? Like, so what does this look like? Well, this kind of looks the same. Yep. The structure's the same. There's our JSON file. We've got our files over there on the right. Yeah. And we can click over there and we can add stuff to our pipeline and add data sources and all the rest of it. And all those things are stored in files. Yeah. And those files can be kept in source control, which is great. Yeah? This picture down the bottom here, right? This looks like it does something. Yeah. Right. And this doesn't do anything because it's just a screenshot, yeah? Which means, in fact, it does the same amount of things as the version of Visual Studio does, right? This is just a picture, a visualization of your JSON file, yeah? That you can, I think you can move the boxes around, but that doesn't really have any like semantic thing to it, yeah? Right, but what we get, in addition to be able to keep our files in source controls, we get deployment, yeah? And so this is or publishing, as they call it in Visual Studio. So here, we can either choose an existing data factory, or we can click on that button there, and we're going to create a new data factory to deploy our code to. Yeah. So what is this going to involve again? Right. Well, this is authentication again. Yeah. So this dialog, or this instance of Visual Studio, has to be authenticated to Azure with my creds, and my creds have to be able to create the data factory or deploy to the data factory. Yeah. And what do we do if we have more than one environment, like this prod, test, and live? Well, there's an answer, right? Deployment configs. So what's a deployment config? Yeah? So do we all remember what a web config is? Yeah. So we had a web config and we had this thing where we could do transformations. Yeah. We had a thing called slow cheater where we could do these transformations in other config files. This is kind of that, right? This enables us, but without the automation, right? This enables us to store like environment-specific stuff in files in our solution. And when it comes time to deploy from Visual Studio, we can pick the file we want, and it will deploy to the right environment. So, can anyone see a catch with that? Well, it is that all of the credentials end up in these config files, like in our source control, right? And that's not an uncommon thing. Never mind Data Factory, right? Everyone here has worked on a project where all the credentials are in the web config files in the source control, right? So really, this experience still, right, is about connected development, right? I'm connected to the database, and I'm doing my thing, yeah? And I can check in my code and all the rest of it, yeah? But this not so I can scale beyond one environment. What I can't scale beyond it is one developer, yeah? Because all this stuff here is owned by me, but there's no way for me to know what else is going on until I click the button here to say publish. Then I find out what everyone else has been up to, yeah? Because there's no opportunity for this integration. Right? I know it's a rule kind of this meetup, the CD meetup, right, that you have to have a reference to Conway's law. Yeah? And I don't really have a proper reference, right? I have an oblique reference to Conway's law, which is this, right? Organizations that sell developer tools are constrained to produce tools that reflect the terrible working practices of the people to whom they market those tools, right? And who are these people? Well, these are the elusive data professionals, right? And I'm not sure I've really met any of these people, yeah? But, so the on-prem systems that these things here are supposed to replace, right? Well, we know what it was like, right? These were developed by like a hobbit that sat in the corner, yeah? No one really talked to him, yeah? And maybe he was kind of from a developer background and thought, yeah, source control, that's kind of a good idea, yeah? Or maybe he wasn't, but no one really knew, right? Because he was just this guy that did the reports or looked after the cube, right? And the reason I'm so intimate with this is that, I've been this guy on many, many occasions, yeah? And no one really cares what you do because this guy is looking after the whole thing. And inevitably, right, in data warehouse land, right, he is the Brent or whatever, right? And your data warehouse always has this bus factor of 1, right, which is this guy, yeah? No one knows it's kind of complicated. He gets paid a lot, yeah? And so these characters are used to working by themselves in their own way and used to being able to bodge stuff in live, yeah? And if you're like a enterprise developer tools vendor, yeah, supporting this use case of being able to bodge stuff in live, yeah, is really important for your enterprise customers. Is there a better way? Well, kind of yes, yeah? And it's in this. So this is Azure Resource Manager, right? So this is their way of doing like deployments and yet again comparing it to something else. So this is like CloudFormation, right? But it has some different twists to it, yeah? Which is that the whole thing revolves around this concept of a resource group, which is a bunch of related things, almost like a tag, yeah? That we can say, right, my solution here has like a database server, this database, this web server, all this stuff, this data lake, yeah? And I can deploy all that in one go to a named thing called a resource group, yeah? And the resource group is also a security boundary, right? So, you can give permissions to stuff in your Active Directory to talk to things in this resource group, right? So this is kind of a handy thing, yeah? And it turns out that almost all the objects we want, not the code, but the infrastructure we want, and infrastructure includes those data factory bits, yeah, which are kind of more code, I think. They're in these JSON files, yeah? So this is what a resource manager template looks like, so I'm not going to go through the whole thing, yeah? But we can see here, no mouse, right? So at the top here, we're passing a bunch of parameters, right? And we're saying, oh yeah, we're setting up a source SQL server, and then we're going to give it, a login and password, and this is what it's going to use to create all these things. There's all the parameters. So here, we're setting up a data lake, give it some stuff.
You can't see that. You can't see that.
You can't see? What can't you see, Prue?
Static picture.
Is mine not scrolling? Oh, bloody hell. Right, how do I recover from this? Right, I think I know.
Can you see the scroll bars on your screen?
Yeah, my scroll bars scroll independently of those ones.
There you go, it's on there.
Right, there we go. So here's the parameters. So there's my data lake, and we're going to tell it some stuff. Here's my data factory. And so one of the interesting things about the parameters, right? If I can find an interesting one. Right, like here. So we're going to say, here's our data warehouse server name, right? But in case I don't give you a name, use this default, yeah? Now one of the things that's going on here, right, is some things in Azure have DNS entries for them, right? That means they have to be globally unique, not just in your subscription or in your group. They have to be globally unique across the whole of Azure, right? And I don't know, there's a list online you can read of which ones are and which ones aren't, right? But what this does is it enables us to create a unique but predictable, right, string based on the name of our resource group. Yeah, so all of our resource group is going to have this name, and all the things that go under it are going to have this, like, predictable names based on the resource group name. Right? That's going to be important in a minute. And we get to the end. I don't have too many slides like this. there are some outputs. And so after we've done all this deployment, this is a funny thing, right? Because we didn't provide parameters maybe, yeah, it's going to tell us what the resources it created were called. Like, and so I only have one more code slide, I think, which is this one. So here's the definition for the data factory, right? Right, so there we go. So here we can see we're creating, our data sets. I'll try and skip through this, right? But so here's all our services that we depend on. Notice there aren't any creds in this file. We're going to pass them at deploy time. And at the end here, this is the final bit of, just a second. At the end, we're going to call some stored procedures, yeah? And this is the final part of our workflow, right? So we've read from the source database into our data lake store. And these stored procedures are going to be the thing that does the polybase thing to load our data from the data lake into our data warehouse. Oh no, there is another code one. Here it is. Right, but I don't need to scroll this one. So here's a stored procedure, yeah? Right, and you'll notice that the first thing it does in my procedure is it's going to create an external table, yeah? So it's saying, oh yeah, that data over there in the data lake, yeah? Like, create this schema definition so I can select from it, yeah? And then, a bit further down, there's a couple of those. And here's the actual loading part. So, we've got our data in the external table, which means it's still out in data lake, in HDFS, yeah? And we've created this external table, which is the metadata that defines it, yeah? Now, one of the things with the massively parallel architecture is that it's much faster to load the data all at once from the store using this syntax create table as, yeah? So how we actually do our ETL, in this case we're reloading the table, yeah? Is we load everything, create table, dim customer new, as select their stuff, yeah? From the external table, yeah? Like, create table as, that was like in Oracle in 1995, wasn't it? But like, it's kind of new here, yeah? Like, and what we do is we select all our data into the new version, we rename the old one, and we rename the new one to the current one, yeah? Now this is a hard thing for like, so people who work with like databases and source control, this is something you don't do, right? Or in general, you don't let your developers like create new objects in their code in the database, yeah? Because it means that you can never have this representation on the outside, like in files or in source control, right? Is your representation of what the database is like current, right? Well, who knows, right? It depends on like what the state of this procedure here is, right? So we needed an approach that wasn't like a regular database source code type approach to manage these data warehouse bits in here. So there are a bunch of tools for managing database source control. Microsoft have some, others have some, yeah? And in general, these tools rely on having some kind of model, right? Like, whether in files or in memory or in a database. And you load all your stuff into this model, then you compare that to what you've got in your database. And then, something happens and they end up the same. Yeah? Right, now what's hard here is that, like, there's this extra SQL Server stuff that is not supported in Azure Data Warehouse, yeah? And then, in turn, there's this other, like, Hy-Vee stuff that is not supported in SQL Server. So the problem that all these tools people have is that none of this stuff is modeled by any of the models, yeah? Because it's all kind of too new and too hard, yeah? So, the smart tools don't really work in this scenario, right? So what we need is some less smart tools, yeah? And migration type tools are less smart, right? And there's a bunch of these, yeah? And so these are really just dumb script runners, yeah? And these involve creating like, a bunch of definitions in some kind of DSL, right? The DSL could be the host programming language, right? I think the Ruby one works like that, right? Like the DSL could be XML or something, right? Like the really hard to use ones work like that, yeah? Like, or it could be SQL, right? And that's how a bunch of tools work as well. So we use SQL kind of as the DSL for defining our SQL objects, yeah? And then we have this tool, in this case DBUP, yeah, like, which is going to run through all of our scripts, figure out what we've done. Like, is anyone familiar with this tool? Not you, right? Yeah, right, and deploy everything that we haven't deployed so far. So this is going to make the state of our database match our source control. So here's a quick look at how I've used DBUP. You'll notice you can get DBUP from NuGet, right? And you can write an exe that embeds your scripts as resources and run that at deploy time, and everything is cool, right? And that's generally the thing to do, yeah? However, you'll notice here, yeah, that I don't have it from NuGet. I've got DBUP local, yeah? And that's because even like a agnostic tool like DBUP required some degree of hacking around to make it work with this Azure Data Warehouse, right? In particular, it relied on some features like identity, right? Or primary key even, right? That are not available, yeah? But the key thing is that these migration type tools are not going to do anything to validate the syntax of your scripts, yeah? Which means you can do things like external tables or distribution keys that are not modeled, and it doesn't know. You get loads of squigglies in Visual Studio, but this doesn't matter. Right? Yeah, right, and then in here, this is a bit of PowerShell, yeah? And we're saying, yeah, deploy our changes into this database, store what we've done in there so that next time we don't run those ones again. Yeah. Oh, and look here, I'm passing some variables in, right? So these external tables themselves need to have creds, yeah, to be able to access the stuff in the Hadoop stores, in the Data Lake stores, yeah. And this is the somewhat difficult to quote correctly parameterization mechanism that we have here for parsing those things. So we figured out a way of doing our database deployments in Azure Data Factory. So where are we? Like in the boardroom, yeah? Well, we've got a big data, yeah? And we've got a hybrid cloud, yeah? No less, we have a data lake. But what's left on the CTO's Christmas list? We need a DEVOPS, yeah? And where are we going to get a DEVOPS? Well, fortunately, there's one in the tin, yeah? Right, so this is Visual Studio Team Services, right? Like, does everyone heard of this? This is TFS, right? Like, but in the cloud, yeah. And I know many people think that TFS is like terminally uncool, right? Like, but I have it on good authority that TFS is really cool now, right? Like, and this is the same good authority that told me that like Windows Phone was really cool and like Silverlight was really cool, yeah. Like, so anyway, stitching all these things together that we've done so far, as we're getting on with time, right? Here's my build definition, right? Now, those of you who don't do database work are going to think, God, what a nightmare this is, right? Yeah, like I've got all these distinct steps in here, right? But what's it all about, right? So all that stuff there is in the Visual Studio solution, which we're going to build at the start, right? And one of the things with database type projects, yeah, is that mocking is a nightmare, right? Like everything has external dependencies. And quite often you have to deploy stuff before you can even like validate that it's working or do any testing or even know that it's going to work, yeah? So this is actually quite characteristic even of like on-prem database type things, is that the build process has all of this deployment type stuff in it that you have to do before you can validate that your releases are good to go. So we're going to do deployment stuff here, right? Like, so this is just plumbing. We have to get our templates somewhere where this can see them. And then we're going to create a source database here. Now the source database kind of in my mind, this is a developer only thing. And in live, the sources are real and somewhere else. Yeah? Right, and the reason we do all that first, right, is that the Data Factory thing is going to start failing if we deploy it before the thing it's reading from, not execute, deploy, right? So you're going to get a lot of errors at deployment, yeah, if it can't validate its external data sources. So we end up doing things in this slightly tortured manner, yeah? And having got all that set up, this is the main event here, right? The resource manager deployment. And you know what I said, right? So we can pass some parameters, and here's all of our parameters, right? But we can tell it what resource group name we want to use. Well, the idea I had is, well, why don't we use the name of the branch, right, to create the resource group? Yeah? So even though all this stuff is like next to impossible to test, like local to the developer's desktop, like you want to do, yeah, but if you work like this, yeah, then what you can do is you can provision an end-to-end environment in Windows Azure just for this branch, yeah. And when you're done with it, you can throw it away again, as we'll get to at the end, yeah. So this provides us with the kind of isolation that is really hard to do if everyone's like using this shared cloud environment, yeah. Like, and then there's some other plumbing that goes on here with permissions. And let me see what I have on my notes. Like, yeah, and then you can't see this here, but the final step, right? If it all works, we're going to like publish artifacts, right? Not to any external like Nexus or anything. VSTS has something built in, right? That step is only going to run if this branch is called master, right? Like, just keep that in your head. Right? So here's our process, right? We create a feature branch, yeah? And VSTS will realize, oh yeah, here's a new branch, right? We're going to do a build, yeah? Because it's a commit on the new branch. And what happens then is we actually create a whole pipeline, yeah? With the data source, the transformations of a target, and we deploy it, yeah? And then we can do more commits and commit new work, and we can carry on deploying to this dedicated environment for our branch. Yeah, like, and then, you know, at some point we create a pull request. Yeah. Now, like a lot of systems, VSTS lets you do like build a merge preview at pull request time. Yeah. One of the things I noticed is if you do that, yeah, and you use this, you know, slightly naive syntax for extracting the branch name, you end up with an environment called merge. Yeah. Because that's the end of the ref spec for the merge build, yeah? You think, well, is that good, is that bad? Well, who cares really, right? Like, it means that you can, you know, validate all this stuff at the point of merging, yeah? And of course, because the resource group deployment's idempotent, we get to reuse it, yeah? Right, and then finally, when we merge to master, well, we have an environment called master, and all of our tests or whatever on the merge code can run in this resource group called master. And finally, at the end of all that, we're going to create a release. And then here's the trick. At the end of this, when we delete the branch, we need to delete the resource group. Yeah, I don't have a slide for this, but you do this with Azure Automation, right? You can create hooks in here that say, you over there, go and delete this branch. Go and delete this resource group. And I'll overname it's named my branch. Yeah. Right. And obviously having all these branches, having all these environments they do cost money, right? Some bits are more expensive than others, yeah? Storage is kind of cheap, yeah? Data warehouses are kind of expensive. They're like between 1 and like N pounds per hour to have up, and they use the expensive storage, yeah? So maybe even some of these other environments you don't want to keep up all the time, right? The production environment you want to keep up all the time, right? Like, but these ones, like for, you know, integration branches and for master or for QA or whatever, well, these things you can throw them away at the end of the day, right? And to give you an idea of the time it takes to build out like that lot, yeah, it takes about 15 minutes the first time, yeah. So that's kind of the overhead when you're creating the branch, right? And 15 minutes is like epic, isn't it, right? But honestly, man, in database land, 15 minutes is nothing. But subsequent deployments to that, depending on what you're deploying, are much faster. They're in the 3 to 4 minute type of zone, yeah, because you're not provisioning all these new things every time, yeah. All right, and so having done all that, a quick look at the release management, right? So this is much simplified, and this is kind of what a release should look like, yeah. So, don't know what the X is. Yeah, so here we're calling the same script again, and this is the thing that's hard to do in these like, you know, off-prem environments. It's like we're using the same code for the developer branches and the rest of it to do deployment as we're using for the, let's say, UAT and production branches. It's all in that resource manager script, yeah? But this time, instead of passing our branch name, we're going to pass, let's say, a permanent environment name, right? Which can be QA or production, right? So we can use the same deployment JSON stuff in all of our environments. But in the developer type environments, we can say, yeah, you just make up a name and tell us what it is and we'll use it and based on this branch. But here we say no, right? This is our UAT environment and it has well-known names, or this is our production environment and it has well-known names. Yeah? And all those things are set up ahead of time. And of course, we can parameterize, the permanent names for the data warehouse, because I think changing the name of your production data warehouse in every release is going to get old with the users, isn't it? Yeah. But that's about it. That's kind of the end of the story and kind of the end of the time. So these are the technical takeaways, right? Like that. Well, if you have to do all this stuff, Azure RM is the way to do it. Yeah. Like, find a sensible way to look after this data warehouse schema, right? Like, a lot of the tools that you get won't work straight out of the box. Yeah. So whatever it is you're doing, so there, DBUP works in most scenarios, but here, a bit of hacking. Yeah. And I think the same would be true of any framework you chose. Yeah. Like, create a new environment per misspelled branch. Right. And then, having done all that stuff, so we still have this like build and release separation, right? We have all that stuff that goes on in developer land, in the integration branches with those environments, and we have this separate thing, which is release management, which we can use to deploy the changes to our permanent environments. And apart from all the stuff on the slide, the real takeaway is, well, you might be like, end up in these things where you're a bit clueless about, what the technology is that's going on. This happens to me like with work all the time, like especially, I help a lot of teams with Jenkins, yeah. And it's like, oh yeah, we're doing this, 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 and this, and we've got some programming language that you've never heard of. That is, but the way to solve all these things, yeah, is to apply like the things that you do know how to do to the things that you don't know how to do, yeah. And that's kind of where I got to with this. So on that, I think we're ready, aren't we?
It's ready.
There we go. Thank you very much.
Thank you.